This statement says use axiom of probability and mathematical induction to prove that if n is more than or equals to 2, then for mutually disjoint sets, the probability of their union is equal to the summation of their probabilities. First of all, note that the union of empty sets is empty. So empty set union with empty set must be equal to empty by definition of general union. So if you want to have an element in the union of empty sets, it must belong to one of those sets, but it's basically impossible. So we assume they are non-empty sets. If A1, A2, A3, A sub I plus 1 are any sets, then we can show that these two sets are equal to each other. The union of A sub k start from 1 to I plus 1 can be written as the union of A sub k start from 1 to I union with the last set, which is AI plus 1. How do we show that? If you take an element from the left-hand side set, we can show that that element lands in the right-hand side set. So if X is in the left-hand side set, basically, we are saying that X belongs to the union. So when you're saying that X belongs to the union, it means that X belongs to one of these sets at least. In case that X belongs to AK, then X belongs to the union of those sets. This is basic definition of union. So X must belong to the union of the first set and any other set. Well, now in the case that X belongs to A sub I plus 1, then it is also true that X must belong to the union of these two sets as well. So from left to right, it is correct. If X belongs to union of A sub k start from 1 to I plus 1, then for sure you can conclude that X belongs to the union of A sub k start from 1 goes to I union with I A sub I plus 1. Now conversely, if you take X in the right-hand side set, then it means that X belongs to the union of A sub k, or X belongs to the second set. In the case that X belongs to the union of A sub k start from 1 to I, then by definition of union, A must be in one of those sets. And it is true that X belongs to the union of these sets along with another set, any other set. And in the case that X belongs to the second set, then it is true that X belongs to the union of A sub k start from 1 to I plus 1, which is basic definition of union. So we just showed that left-hand side and right-hand side are equal to each other. We're using this and mathematical induction to prove the statement. Let the property Pn be the sentence if A sub 1, A sub 2, A sub n are mutually disjoint events, then the probability of A sub 1 union, A sub 2 union, A sub n is the summation of their probabilities. I start 1 goes to n. So this is our hypothesis. Now, our goal is to show that it is true for I plus 1 as well. First of all, note that P of 2 is true. If A1 and A2 are mutually disjoint events, we know that by the third axiom of probability, the probability of A union B is equal to probability of A plus probability of B. So if you just call A A1 and B A2, the probability of A1 union A2 is the probability of each one, and then add them together. So the basic step is true. Now, if you assume that for any I more than equals to 2, Pi is true, our goal is to show that P of I plus 1 is also true as well. Let us begin. We have our inductive hypothesis, which is P of I. We say that, hey, suppose this is true. If you have mutually disjoint events, then the probability of A1 union A2 union A3 union AI is equal to the summation of their probabilities. Now, our goal is to show that it is true for I plus 1. It means that we need to show that the probability of A1 union A2 union AI union AI plus 1 is equal to the summation of their probabilities. But how we're going to do that? First of all, we know that these sets are mutually disjoint. By observation, we know that A sub I plus 1 intersection with the union of these mutually disjoint sets can be written as, remember, intersection can be distributed over union. So you can write it as A sub I plus 1 intersection A1 union with A sub I plus 1 intersection A2, and finally AI plus 1 intersection AI. Well, A1 union A2 union AI plus 1 is nothing but the union. You can group these together. A1 union A2 union AI union the last set. So, because set A1, A2, and AI plus 1 are mutually disjoint, it's equal to empty set, union empty set, union empty set, which is going to be empty. See what's happening here. So A1 union A2 union AI and this set are disjoint. What's the meaning of that? It means that if you apply the third axiom of probability, the probability of A1 union A2 union AI plus 1 is the probability, if you group these together now and call it, for example, A and this guy B, it's equal to the probability of A plus the probability of B. Well, by inductive hypothesis, this probability is equal to the summation of P of A sub k start from 1 to I, plus the probability of A sub I plus 1. If you combine this together using summation, you get the sum of the probability of A sub k start from 1 to I plus 1. So we just showed that P of I plus 1 is also true. So by the method of induction, we just proved this statement.